Exciting developments are coming out of Google's DeepMind. They've created a groundbreaking method for training AI models that's not just faster, but also significantly more efficient. This innovative technique is called JEST, which stands for Joint Example Selection.
Trust me, it's a game changer.
Let's dive in. If you're familiar with AI, you know that training these models typically requires immense amounts of time and computing power. It's like trying to teach a child every subject in school one by one, super energy intensive. Systems like ChatGPT, for instance, consume a lot of power and water to keep data centers cool, with energy demands often compared to Bitcoin mining.
Yes, it's that extreme.
But here's where JEST steps in. The researchers at DeepMind have devised a way to make the entire training process far more efficient. How much more efficient, you ask?
We're talking up to 13 times fewer iterations and 10 times less computational power.
That's a significant breakthrough in terms of both speed and energy consumption. So, how does JEST work? Traditionally, training involves selecting individual pieces of data. JEST, on the other hand, examines groups or batches of data, picking the best ones that complement each other. Imagine trying to learn multiple languages, not just English, then German, then Norwegian separately, but studying them in a way that what you learn in one language helps you understand the others. That's essentially what JEST does with data. On a technical level, JEST employs a method called multimodal contrastive learning. This approach involves looking at different types of data, such as images and text, together and identifying dependencies between them. This significantly accelerates the learning process because the AI can learn from well-matched data batches much more efficiently. Another cool aspect of JEST is its use of a pre-trained reference model. This model guides the AI towards high-quality, well-curated data, making the training even more efficient. The study showed that using JEST, they could achieve the same performance as traditional methods with up to 13 times fewer iterations and 10 times less computational power. In terms of energy consumption, that's a massive reduction, which is fantastic news for the environment. This research is timely as the tech industry and governments worldwide are starting to discuss AI's extreme power demands. To put it in perspective, AI workloads consumed about 4.3 gigawatts in 2023, almost equivalent to the annual power consumption of the entire nation of Cyprus. And this trend is only increasing. A single ChatGPT request currently uses 10 times more power than a Google search. It's estimated that AI could consume a quarter of the United States power grid by 2030. Therefore, a method like JEST that drastically reduces the power required for training AI models is incredibly significant, potentially alleviating both environmental and financial pressures. However, the success of JEST depends heavily on the quality of the training data. The bootstrapping technique used by JEST requires a highly curated initial data set to be effective. This means that while JEST shows great promise for large-scale, well-funded AI projects, it might pose challenges for hobbyists or smaller developers who lack the resources to compile high-grade training data. Essentially, this method underscores the old adage, garbage in, garbage out, emphasizing the need for top-tier data to achieve optimal results. If widely implemented, however, JEST could revolutionize how major players in the AI industry approach model training, possibly reducing costs and power consumption while accelerating development timelines. Another neat feature is something they call data quality bootstrapping. It sounds fancy, but it's straightforward. It involves using a small, highly curated set of data to guide the training on a much larger, messier set of data. So even if you start with a tiny, excellent dataset, JEST can help you scale up to train on vast amounts of data efficiently without losing quality. This is a big deal because high-quality datasets are usually hard and expensive to create. This method isn't just limited to one type of data or task. It works across various benchmarks, making it versatile. For example, they tested it on a dataset called WebLI, a large-scale collection of images and texts from the web. The results showed remarkable improvements in both learning speed and resource efficiency. If JEST proves effective on a larger scale, it could drastically reduce the power needed to train AI models. This means we could develop more powerful AI tools with the same resources we use now or use fewer resources to create new models. Essentially, we're looking at faster technological advancements, less strain on our energy resources, and a smaller environmental footprint. It's a win-win-win. Now, shifting gears a bit, big AI companies in China have been making some major claims about their large language models at a huge AI conference recently. It's like a competition to see who can boast the most impressive advances. For instance, SenseTime, a big player in the AI game, unveiled the latest versions of their Sense Nova LLMs. They claim the new 5.5 model is 30% better than the previous one from just a few months ago.
Wild, right?
The CEO, Xu Li, was on stage hyping it up, saying that the key to success in Chinese AI is building high-level logic systems using synthetic data for different industries. Xu claimed that this 5.5 model supposedly outperformed GPT-4, the latest and greatest from OpenAI, in 5 out of 8 key metrics according to some benchmarking data from a platform called OpenCompass. Take that with a grain of salt, but still, that's a pretty big flex. Despite these huge claims about their model's performance, SenseTime's stock price actually dropped by 16% on the same day in Hong Kong.
Crazy reversal, right?
You'd think investors would be thrilled about a model that can supposedly take down GPT-4, but I guess the market had other ideas. And it's not just SenseTime making noise at this conference. Alibaba's cloud division, the folks behind the Tongji Qianwen LLMs, bragged about millions of new downloads and a surge in customers for their AI platform in just the last couple of months. The CTO, Zhou Jingren, pushed the open source angle hard, saying their models are now fully open source and closing the gap with closed source ones from the big Western players. Smart move. If you ask me, it makes their tech more accessible and gets more eyes on it. Here's the wildest part. Yan Junji, the CEO of AI startup Minimax, predicted that in the future, there will only be about 5 companies making these huge LLMs globally. That's a hot take, right?
Could you imagine that kind of consolidation,
with just 5 players controlling the entire large language model space worldwide? Insane to think about. Of course, Yan didn't say how many of those would be Chinese companies, so we'll have to wait and see. But the implication is clear. He thinks there's a real chance for Chinese firms to be among that elite group someday. Oh, and back to SenseTime for a sec. They also showed off a couple of other new models at the big Shanghai conference. The first is called 5. It's a multimodal model that can combine different data types like text, images, and video into one seamless experience. They did a live demo with 5 that was low-key mind-blowing. A SenseTime employee on stage took a video of himself standing there, seemingly nothing special. But then, the 5 model instantly identified that he was attending the World AI Conference just from analyzing his staff badge and t-shirt in the video.
Wild, right?
It gets even crazier. The model could then answer follow-up questions about what the conference was for and all the details, achieving true understanding from just that little video clip.
We're talking next-level multimodal AI capabilities here, folks.
Between the bold performance claims, the open-source pushes, the predictions of an LLM oligopoly, and the impressive tech demos, it's been an absolute whirlwind of big moves and even bigger ambitions from the Chinese AI giants at this conference. And that's not even getting into what companies like Baidu and Tencent were unveiling. It's definitely an exciting time in the AI space, and it'll be fascinating to see how all these moonshot plays actually pan out in the real world.
Can the Chinese models really take down the Western juggernauts? Will we see a small group of ultra-dominant LLM providers emerge globally?
So many intriguing possibilities. One thing's for certain. These Chinese tech companies are clearly not messing around. They've got their sights set on AI supremacy, and they're going all in to make it happen, whether through cutting-edge R&D, savvy business strategies, or sheer bravado and ambition. If you found this interesting and want to stay updated on more AI insights like this, don't forget to subscribe to the channel. Thanks for watching, and I'll see you in the next one.